like old school stuff too, so it's not like I'm doing something. All right, so chapter 9 deals with genetics. Genetics is really cool. Of course, if you were a major, you probably would have to take a genetics course, and we're just going to spend one chapter on it, which is, but you'll at least get a little bit of taste of how all of this works and how things can be passed on from parents to offspring, right? So genetics is the study of heredity, which is the study of the passing of information from one generation to the next. And, from probably the Greeks all the way up through the 1800s, it was believed that all the genetic information, well, they didn't call it that, but all the traits that a person has is a result of just sort of a mixing of all the traits from your parents into a big pot, and the pot is you, okay? And you come out whatever, okay? And that's called the blended theory, and that was, like we talked about fact, or proven. That was pretty much, the standard thinking for a long time, all right? Until along came a Austrian monk who tipped all that on their edge, and actually started to explain how traits were passed on from parent to offspring, right? So blended theory. And then in the mid-1800s, there was an Austrian monk by the name of Mendel. He is known as the father of genetics, all right? And he was trained in statistics. He was a statistician. But he went to this monastery, and they gave him the honor of growing peas, all right? So he was a gardener, with a statistics background, all right? And so they had greenhouses, so they could grow them all year. The thing about peas is you could have several generations in a growing season or a year. So he was in charge of growing all these peas. The thing about peas are, I can grow them, so if I can grow them, just about anybody can grow them. They're hard to kill, all right? But they have some certain traits that are very, very, that you can see very well. And so he was just going along, looking at his plants, and taking care of his peas, and he started noticing that certain traits in some plants were different than most of the others. And so that started his statistical mind going. And so he decided that if he watched these traits over several generations, then he could possibly tell what's going on about the genes that were being passed on from each generation to the next. Okay, so he set out looking. Peas have either purple or white flowers. They have. Anybody eat English peas or green peas? All right, I do. Some people hate them. My kids. If you get in a can, you'll see some of them have a wrinkled shell, and some of them are smooth. Most of them are smooth, but some of them have wrinkles, okay? That's a trait, all right? Some of them were tall. Some of them were very short. Some of them had a green pod. Some of them had a yellow pod, all right? And so there were several of these different traits, and so they lent themselves fairly easily to experimental testing, right? So, Mendel used a scientific approach, all right, just like we talked about in chapter 1. Why was the pea test organism easy to grow? Just like I said, they reproduce very quickly. And the flowers, really interesting. Some flowers, well, a normal flower will have like its petals, and then they have a female part, and then they have male parts like this, right? And a pollinator comes flying in, all right? And there's nectar down here. So he comes in, he's fooling around with the nectar. He rubs up against the male part where the pollen is. And then he goes flying off to another flower, right? And when he gets to that flower, he rubs up against this top portion of the female part. It's like Velcro. It catches those pollen grains, and then that flower is pollinated, all right? That's normally how it's done, okay? Oh, we'll talk about all that here. It's chapter 17, all right? But in the case of, bless you, yeah. Peas, their petals cover all of the reproductive parts, okay? And so when the anther makes its pollen and there's no pollinator to come by, the pollen just drops down, sticks to the stigma, the styling of the female reproductive part, and then they sperm pollinate, fertilize the egg. Okay, this is called self-fertilizing. All right, so they sort of can make clone-ish type of deal going on. All right, and so what makes that so good for a test organism is if you snip the male parts, okay, that